Welcome everybody. In this presentation, I would like to give you an academic perspective on a day in the life of a data scientist. My name is Bart Baesens. Let me briefly start by introducing myself. I studied at the KU Leuven, Belgium. My master's degree is business engineer in management informatics, and I also obtained my PhD at the Catholic University of Leuven in 2003. I'm currently a professor of Big Data and Analytics at KU Leuven, Belgium, and a lecturer at the University of Southampton in the United Kingdom. My research focuses on Big Data and Analytics. I have a research team of about 10 PhD students, all working on Big Data and Analytics. Some of them work on developing new techniques, whereas other ones are going to focus how to use those new techniques in application areas such as credit risk analytics, marketing analytics, HR analytics, social network analytics, etc. My research group is called Data Mining Apps, and you can find all information about it on my website www.dataminingapps.com. You will see the various research tracks there, publications, you will see some movies about some of our research projects, and you will also find various links to our corporate partners, because most of the research that we do is in close collaboration with the business world. In case you would have any questions about this presentation, feel free to email me at the address indicated at the bottom. Here you can see some of my example publications. The top row are books related to analytics in a big data world and a Chinese translation thereof, fraud analytics, and credit risk analytics. The bottom row are my most recent books: Profit-Driven Business Analytics, Credit Risk Analytics, the R Companion, a book which we are soon going to publish, let's say in a week or so from now, Web Scraping for Data Science with Python. Web scraping is a very exciting data collection technique whereby you're going to scrape all types of information from publicly available websites. And finally, our most recent book, which is not available yet, although we already submitted the files to our publisher, Cambridge University Press, is Principles of Database Management. That's a quite big book, will be around 1,000 pages, should be available by end of June 2018. Okay, so let's have a look at the data science process model. When you do a data science project, you always start from a business problem. The business problem could be, we would like to reduce churn. Churn means that customers are going to leave your organization and buy your product or buy a product or service elsewhere. Think about telco operators. Telco operators are faced with typically very high churn rates. Your business problem could also be fraud. You want to identify fraud first, you want to detect fraud first, and in a second stage you want to prevent fraud from happening. So it's very important that a data science process is always initiated from a business problem. In a second step, you're going to identify data sources, various types of data sources. Those could be internal data sources, transactional data sources, or could be external data sources. Think about my earlier book on web scraping. Web scraping, or information that you scrape from publicly available websites, could be very interesting information to help you solve your business problem. Once you have clearly identified all data sources that could be of potential interest, you can start selecting them, bringing them together in a data staging area, and then cleaning the data. Cleaning the data means that you're going to get rid of things like outliers, missing values, inconsistencies, duplicate entries, etc. Cleaning is a very important step because of the GIGO principle. Garbage in, garbage out. Bad data gives you bad models, right? So if you mess up your cleaning phase, you're going to mess up your analytical modeling. Transform the data is a very important step. In this step, you're going to do what I often refer to as feature engineering. That means you're going to create features that enrich your data. A popular example of a feature is age. No company stores the age of their customers. Why not? Because it varies, hopefully, on a yearly basis. Companies store the birth date. So you're going to derive the feature age from the birth date. That's obviously a very straightforward feature, and there are other types of features that you can think of and derive from your data. Next step, you're going to analyze the data. So you're going to use a data science technique, data science algorithm, like a decision tree, a neural network, or maybe even a regression model. The regression model or decision tree wants to differentiate the churners from the non-churners, the fraudsters from the non-fraudsters, the defaulters from the non-defaulters, etc. There's various types of data science techniques available these days, and that's exactly one of the problems when you want to apply data science in a business setting, right? There's so many data science techniques available that it's often unclear which one you should use when and for what purpose, all right? In this presentation, I'm going to try to give you some guidance on that. In a final step, you're going to interpret the model. You're going to evaluate the model in various ways and then deploy it, which means you're going to bring it into production. You're going to make a scoring application, a decision support system, an expert-based system, which is basically steered or based upon an underlying analytical model. There are plenty of applications that you can think of, and here I've listed some example applications without claiming to be exhaustive. There's fraud detection, but there's even various types of fraud. There's payment transaction fraud, there's credit card fraud, there's insurance fraud, various types of fraud that you can think of, and which we also discuss in one of our books on fraud analytics. This market basket analysis. Market basket analysis means that you're going to try to figure out what products are frequently purchased together. Think about a supermarket, or think about recommender systems as they're being adopted by Amazon or Netflix. Netflix wants to figure out what movies are frequently purchased or rented together, whereas Amazon wants to figure out what books or games are frequently purchased together. I'm not going to go through the entire chain of applications, but customer lifetime value is another example of analytics, whereby you're going to model the CLV, or customer lifetime value, which is the total value that a customer is going to generate during a particular period of time. Churn prediction is the example we already gave, right? In churn prediction, you want to predict what customers are likely to leave your organization and buy your product or sell or service with a competitor. Let's give an example of churn prediction and customer lifetime value. Here you can see an example of churn prediction. Basically what you're doing in analytics is you gather a set of observations, customers, right? So plenty of customers, which you're going to describe with a set of variables or features. Right? Here you can see 4 features. The age, which was derived based upon the birth date, and then the recency, frequency, and monetary features. The RFM features are a popular set of features which are often used in marketing analytics. The recency indicates how long ago since a purchase was made. The frequency indicates how frequently purchases are made. For example, how many purchases are made on average on a weekly, monthly, or maybe even daily basis. The monetary feature then indicates the average amount of the purchase. These are examples of features. Remember, in features are not readily available in your underlying data systems. You should derive them in close collaboration with a business expert, something we're going to come back to later on. And then you have a target indicator, something you wish to predict. In this case, it's churn. And for these customers, we have their historical churn behavior. So we know which ones churned historically and which ones did not churn. And our whole analytical exercise now boils down to discriminating the churners from the non-churners using some type of analytical model. Here, our target is categorical. It's binary, yes or no. It could also be continuous. That could be an example of a CLV modeling exercise. Customer lifetime value modeling means that, as I said, we're going to model the lifetime value of a customer. Note, we can never predict in the future, right? Some firms that we collaborate with often ask me, Bart, how far ahead can we predict? Well, prediction is always a bit of a informed guessing, informed based upon your data. In terms of CLV modeling, I always recommend firms to work with a 2 or 3 year forward-looking time horizon. That means try to measure the customer lifetime value during a 2 or 3 year period. Further ahead becomes really difficult to predict because of all the uncertainties involved. Here you can see an example of a CLV modeling dataset. Again, we use plenty of features. I've only listed 4 features here like age, recency, frequency, and monetary, but there's plenty others that you can use. The rule here is the more the better, because your analytical technique will automatically figure out which are the important features and which are the non-important features. In other words, which are the features that contribute to the CLV and which are the features that do not contribute to the CLV. These are just 2 very simple examples of analytical modeling exercises. When you do a data science project, you have to set up a data science project team, right? And I know that some of the organizations right now are experimenting with agile organization methods to work out their data science projects. But basically, here you can see the different roles that you need in a data science project team. You need a database or data warehouse administrator. He or she will provide you with the key ingredient of your analytical exercise, and that is data, all right? That's very important. He or she knows where the data resides, knows the data definitions, etc. That's very important. The business expert, that could be a marketeer, that could be a credit risk analytics, that could be a credit risk analyst, that could be a fraud analyst, that could be an HR analyst, that's somebody non-IT related, but who will end up using the analytical models to facilitate or optimize their business processes. This person plays a crucial role because he or she will help you frame the business problem from which you will start your analytical model exercise, and then also validate the insights that come out of your analytical exercise, right? Because it's really important to gain trust in your analytical models that you clearly validate the outcome of your analytical models in close collaboration with your business expert. Only then he or she will trust the model and will actually use it to in their daily decisioning tasks. A legal expert is getting more and more important because there's more and more data that we can use. Think about the big data, the concept of big data, right? There's so much data that we can use, but the question is, what are we allowed to use, in what ways, and what are we not allowed to use? Think about the web scraping example I gave earlier. Web scraping means that you're going to scrape information from the web. There's a lot of legal concerns about when you can do it and when you cannot do it. You should ask that to LinkedIn, for example. They are regularly involved into lawsuits whereby they kind of sue firms. Like a recent example was a firm called HIQ that scraped LinkedIn information to see whether employees are likely to churn, yes or no. How could you scrape LinkedIn information to see whether employees are likely to churn, yes or no? Well, you just see when people are start to update their LinkedIn profile. If people are if employees start to clean up their LinkedIn profile to update it with new information, it could be a very important sign to say that they're on the lookout for other types of jobs. The legal expert will tell us exactly what data we can use and what data we cannot use. Think about cookies, think about all kinds of other data that is available on the web. Think about social media data, like Facebook data, like Twitter data, etc. The data scientist will then analyze the data. He or she knows everything about logistic regression, decision trees, neural networks, support vector machines, k-means clustering, deep learning, how to develop those models, and how to evaluate them afterwards. And there's obviously the software and tool vendors. Think about companies such as SAS, such as IBM, such as SAP, such as Microsoft, etc. Or even think about open source solutions such as R, Python, and so on, where you have software communities. In other words, when you're doing these data science projects, it is clear that you need a multidisciplinary team. Organizations often approach me and say, Bart, we're on the lookout for data scientists, but if we hire data scientists, what should we be looking for? Well, here I have a set of skills which I believe a data scientist should possess. First of all, a data scientist should be a good programmer. He or she should be capable of working out programs in any type of programming language, be it R, be it Python, be it Julia, be it Java, etc. The language doesn't matter that much as long as that person is familiar with programming concepts. A data scientist obviously should also have solid quantitative modeling skills. He or she should be familiar with regression methods, decision trees, how to construct a decision tree, how to interpret a decision tree, how to evaluate a decision tree, and how to implement a decision tree. Likewise, with neural networks, with SVM, support vector machines, ensemble methods, etc. Since a data scientist will operate in a multidisciplinary team, together with a business expert, together with a legal expert, etc., he or she should also excel in communication and visualization skills. Visualization is often used to bridge communication gaps. You may have heard of visual analytics. Actually, the premise of visual analytics is to bridge communication gaps between, for example, the data and the data scientist on the one hand, but also between the data scientist and the business user on the other hand. If you can visualize complex models in an attractive way, it will create trust in those models and people will start using them. Obviously, preferably I should say, a data scientist should also have a solid business understanding. That's why it's very important that he or she closely collaborates with a business expert, be it a credit risk analyst, a marketeer or fraud analyst, etc. And finally, a data scientist should be creative. He or she should know how to leverage new technological developments. Think about the Internet of Things, think about drones, etc. How to use that to their analytical advantage. Now, with this introduction being covered, let's now have a look at some analytical evaluation criteria. And when I said that I'm going to give an academic perspective on a day in the life of a data scientist, basically one of the things I always complain about is that many academics nowadays, when they talk about analytics, they focus on accuracy, on developing statistical meaningful and statistical accurate models. When I say accuracy, I really mean it in statistical sense. I'm referring to things like correlation, R-squared, mean squared errors, area under the ROC curve, Gini curve, lift values, Kolmogorov-Smirnov statistics, likelihood ratio statistics, etc. There's a whole bunch of those statistical evaluation metrics which I almost dare say academics are obsessed about. And that's not what I think should be the focus in analytics or data science if you want to bridge the gap to the business world. Because in business settings, interpretability can get very important. In many business settings, not in all, but in a majority of business settings, it is of key importance that analytical models are interpretable. I'm going to come back to that in a moment. They should not only be interpretable, but also operationally efficient in certain settings. If you do online real-time fraud detection, then you would like to make a decision as soon as possible as to whether a particular payment transaction is fraudulent, yes or not, such that you can block it. And finally, at the end of the day, business people are not that much interested in all these accuracy-related measures, all these complex statistics, but they're interested in the bottom line impact of analytics. In other words, in profit. What will be the impact profit-wise of my analytical models? That's why one of my most recent books focuses on profit-driven business analytics. How can we focus data science techniques? How can we focus analytical models towards profit? How can we directly embed profit not only in the model evaluation, but also in the model training or in the model estimation? That's why we have developed right now in my research group various types of analytical techniques like ProfLogit, which is logistic regression but with a profit focus, ProfTree, which is decision trees but with a profit focus, and ProfArima, which is a forecasting technique called autoregressive integrated moving average, which is one of the most popular forecasting techniques, but whereby we focus on profit. So a very important message which I would like to convey with this slide, it's not only about accuracy, which lots of academic research primarily focuses on, but it's also about the interpretability, the operational efficiency, and obviously also about the profit. Let's zoom in on each of these components into a little bit more detail. First of all, interpretability. Interpretability is a key concern in settings which are heavily regulated. Think about credit risk modeling. Credit risk modeling is a setting which is heavily regulated by all types of regulatory guidelines, like the Basel Accords and IFRS 9. They are regulatory guidelines which enforce lenders, be it financial institutions or other types of lenders, to build credit risk models that evaluate the creditworthiness of their customers. Those credit risk models, given their strategic impact and given their widespread usage throughout the firm, those credit risk models should be white box models. And when I say white box models, I'm referring to the fact that they should be based upon simple underlying analytical techniques which are easy to explain to business users that need to use them to actually decide whether a customer will get a loan or will be rejected. Same goes for medical diagnosis. In all types of medical studies, for example, in the US, we have the Federal Drug Administration body that kind of enforces analytical companies that do medical studies to use white box methods so that you can clearly see what's happening when you study the effect of certain medicine. In fraud detection and especially prevention, we also need white box models. Fraud detection means that we're going to detect whether a transaction is fraudulent, yes or no. So there, the white box aspect is not that important, but when you want to prevent fraud, it's really important that you understand the fraud mechanism. Hence the need for white box applications. I would like to stress, however, that not every application needs white box models. Certain applications are perfectly fine using black box models. And when I say black box models, I mean complex analytical models. And let me give you some examples. I'm thinking about neural networks. I'm thinking about deep learning techniques. I'm thinking about support vector machines, for example. Those techniques can be successfully used in response modeling, for example, right? Response modeling means that you're going to model whether somebody is going to respond to your marketing campaign, yes or no. Or in image analytics, think about Google image search. Google image search is an example of an application where you can perfectly use a black box complex model to do an image search or to look for images that match a given image, right? In those applications like image analytics or even text analytics, black box models can be perfectly successfully used, right? So you see, a very important takeaway from the slide is that interpretability is a key concern in certain applications. Here you can see an example of how interpretability can be achieved, and it's basically all about visualization. To the left, you see a logistic regression model. A logistic regression model is basically like a linear regression, but where the outcome is limited between 0 and 1 such that you can interpret it as a probability. So here we want to estimate the probability that a customer is good, given his or her age, gender, salary, etc. You can see the formula to the left, right? You can see this e-power transformation that basically limits the output to between 0 and 1 such that you can interpret it as a probability. To the left, you see the #1 analytical model used in the industry nowadays. This is used by lenders to decide upon your creditworthiness. This is used by telco operators to decide upon whether you're going to churn, yes or no. This is used by insurance providers to decide whether a certain claim is fraudulent, yes or no. But you can see it's not that complex a mathematical formula, but for certain types of business users, it may not be that evident to use it. And that's why scorecard visualizations have been developed, as you can see to the right. To the right, you basically see a scorecard visualization of the same logistic regression model. So the scorecard visualization to the right gives you an exact representation of your logistic regression model, but in a more attractive way, because we have all our characteristics like age 1, age 2, gender 1, gender 2, 5 salary categories, each with a particular category definition, and to the right we have points associated. More points means better creditworthiness. So it's a very nice, attractive visualization of an underlying powerful analytical model that can be used to gain trust by our business users. That's not the only visualization. A visualization that we've been working on in our group based upon a recent paper we read was nomograms. Here you can see a color-based visualization also of a logistic regression model. And this was for predicting stroke, for predicting the risk of stroke, right? So to the right, you see the color legend, which goes from dark green, which means no risk, up to something which is more like white with a scale number of 10, which indicates high risk of stroke. To the left, we see our variables, or features if you want. So we see the gender or sex, and we can immediately see that females are at higher risk than males because they have a lighter color. In terms of age, we can see that the older you get, the more likely you are to suffer a stroke. Systolic blood pressure also indicate higher blood pressure, more likely to have a stroke. Diabetes patients are also more likely. When you had a prior stroke, you're also more likely. You can see these are very straightforward insights that you can get out of these nomograms in a very easy way. You may have heard of all the buzz surrounding deep learning, and deep learning is a very powerful set of techniques, but don't be too obsessed about it, right? In what follows, I'll give you a little introduction to deep learning. I cannot do that into a lot of detail during a couple of minutes, but I can give you the idea. A deep learning is essentially a multi-layered neural network. It's a neural network that consists of various processing elements. You can see some processing elements here, which have been arranged into layers and which give you a certain output. So to the left, you feed the neural network, the deep learning neural network, with various inputs like recency, frequency, monetary. It performs plenty of complex calculations, and out comes a number that could reflect your churn probability or your customer lifetime value estimation, for example. Very complex analytical methods. Here you can see some examples of applications of deep learning. So to the upper left, you see deep learning can be used for image coloring. So you can feed a black and white image to a deep learning neural network and it will color it for you. It can also be used for image captioning to see, like in the upper right corner, you can see a dog jumping over a bar. So the fact that there's a dog and a bar in there can be learned by a deep learning neural network. Or for object detection, as you can see in the lower left, or it can also be used for translating text from an image. You can see in the lower right corner, you can see there are certain types of cookies with some kind of, I don't know what the language is, but it looks a bit Scandinavian to me. Well, you can learn a deep learning neural network that is going to look at what's in this image and then translate it to the language you want. Very important is that just as any analytical model, when you do a deep learning exercise, you always have to provide it with a learning set. Deep learning is nice, it's powerful for these image processing applications and for text analytics, but when you do it, you have to be really careful because you lose on interpretability. I see too many firms right now in the industry being too much obsessed about deep learning. It's a nice set of techniques, it's powerful, but do not blindly start developing, estimating deep learning models, or you're gonna drown in a huge technical swamp, if I may say so, because it's really complex. In my PhD, which I finished in 2003 and which you can download for free from my website, I studied how you can make those complex deep learning alike. It wasn't named deep learning at that time. It was more named like multi-layer perceptrons. How you can make those complex models a little bit more interpretable, how you can shed some light on their internal functioning and their internal thinking. And one thing I did was, we started from a neural network, and here you can see one of the neural networks that I trained in my PhD in collaboration with a Belgian bank to do credit scoring, for example. So you can see to the left, you have various types of inputs. You can see all the neurons which perform certain types of complex calculations, and out then comes a classification whether a credit applicant is good or bad. So we started from that neural network, and we realized if we're going to present that neural network with all the complex transformations inside, which are hidden on my slide, and we present that to the business user, it's not going to generate the trust we want. People are going to be reluctant to use it because, I mean, they don't understand what's going on. So in my PhD, I kind of looked at how we can extract rules, propositional if-then rules. Here you can see a set of rules that we extracted from that network, and that kind of clarifies how the network works. So if you would have to choose between a complex network, which I showed you on my previous slide, and this set of rules, probably you'd go for those set of rules because they're a lot more transparent, they're a lot more white box. And that is, I think, what we should focus on if we want to bridge the gap between analytics or data science as an academic discipline and as a business enabler. We should really make it more interpretable by thinking in terms of those rules. We actually took it even one step further in my PhD and represented it as a decision table. Here you can see the rule set of my previous slide, but now represented as a decision table, which is much like a top-down structure where you're going to navigate through the various conditions one by one until you arrive at a classification at the bottom. So see, you're going to see whether the savings account is less than or equal to 12.40 or if it's bigger than 12.40. So you can see that as soon as somebody has some savings amount of 12.40 euros, they are considered to be a good payer in this particular case for this particular data set. In case not, we have to look at the other criteria such as economic sector, purpose, term, years client, and navigate ourselves way down the decision table until we end up with a decision. What about operational efficiency? Well, operational efficiency primarily relates to the time that is needed to evaluate the model. How much time do we need to calculate a churn score? How much time do we need to calculate a fraud score? Or a CLV estimate, right? Or a sales estimate? Obviously, that highly depends upon the setting. If you do sales forecasting, usually, operational efficiency is not an issue. You can take some time. You can take a few hours to calculate sales forecasts. If you do credit scoring, unless you would do online real-time credit scoring, but in most cases, if you calculate a credit score, the operational efficiency is not a key concern. It becomes a key concern if you're doing fraud detection, for example. And if a transaction needs to be scored in terms of its likelihood of being fraudulent. We collaborated with a credit card provider, for example, where we were faced with a limit of 8 seconds during which we had to make a decision whether a transaction was fraudulent, yes or no. So their operational efficiency is a key concern. Sometimes you have to sacrifice part of your accuracy, part of your statistical accuracy in order to gain operational efficiency. Operational efficiency depends upon the complexity of the data that you feed the analytical model. How complex are the features, for example? Does it take a lot of resources in terms of ETL, extraction, transformation, and loading of the features, right? If you have those RFM features, how much time are needed to calculate those? But also in terms of the complexity of the model. What type of models are being used in terms of complexity? If-then rules are very simple analytical models. You can just implement them in Microsoft Excel like that. But if you would resort to deep learning models, those are a lot more complex and will require a lot more operational resources in order to use them. And also, obviously, the complexity of the software, right? Do you have a melting pot of software which is interfacing in various ways, which again hampers your operational efficiency, or do you have an integrated solution where you can quickly screen transactions by doing the necessary software calculations? Again, note that operational efficiency is not always a key concern. In fraud detection, when you want to score transactions as being fraudulent, yes or no, it is a key concern, whereas in other settings, it is not. Another one, a final thing, is profit. At the end of the day, if you're a business, you're primarily driven by costs, profit, return on investment, total cost of ownership, and so on. And as academics, we've used profit primarily in two ways. The first way in which profit became important in academic research is as an ex post evaluation metric. With that I mean, we build a decision tree, we build a regression model or a neural network, and we calculated its profit afterwards. That's already a step in the good direction. But we can do better than that. We can not only use it ex post, but we can also directly embed profit in the model building. And that's exactly the type of research that we're doing in my group nowadays. We're embedding profit in the model building. So we're no longer gonna build logistic regression models based upon statistical objectives like maximizing the likelihood function, We're no longer going to build decision trees which are going to minimize impurity measured using Gini and entropy, but we're going to directly inject profit as a criterion in these techniques. And that's how we developed ProfTree, which is decision trees that directly optimize profit. That's how we developed ProfLogit, which is logistic regression that directly optimizes profit. And that's also how we developed ProfArima, which is a forecasting technique that directly optimizes profit. So the focus is now primarily on the economic value rather than the statistics. By the way, if you'd be interested to stay in touch about all these developments that we're doing in the area, go and have a look at our dataminingapps.com website. You'll find plenty of information there. And there's also a newsletter which we send out on a 2-weekly basis that keeps you informed about all the research we're doing. You can subscribe to our Data Mining Apps newsletter on our website, and you'll get 2 weekly updates in case you would be interested to stay in touch about all this work we're doing. Just to show you the impact thereof, here you can see ProfTree in action. To the left, you can see a card that says classification and regression trees. It's a statistical decision tree, right? It's a statistical decision tree where the splits are made using all types of impurity criteria. For card, this is the Gini criterion for those who are a little bit more familiar with how this method works. Card is a very important decision tree technique primarily focused on optimizing a statistical objective function. Again, I don't think this is the right focus if you want to use data science in your business projects. You should focus on profit. And to the right, you can see we started from the same data, but we kind of adjusted the decision tree induction mechanism to directly optimize profit. And when we measure the profit that is being generated by our tree versus the profit that is being generated by the card or statistical tree, we see that there's a difference of 1.19 euros per customer. That's only for one customer, but imagine that you would have millions of customers, then obviously this turns out into a very significant and important number. And this is just by shifting the focus from a statistical objective towards a profit-oriented objective. Okay, so what are the conclusions of this academic perspective on the day of a life, in the life of a data scientist? Well, I think that academics, including myself, by the way, I'm not putting the blame with the others. Sometimes, I want to also look at myself, but oftentimes we as academics focus too much on things which are not that very relevant in business settings. We focus too much on statistical criteria rather than looking at interpretability, operational efficiency, and profit. I think as a business, if you really want to compete using analytics, you want high-performing analytical models that in certain settings are interpretable, are operationally efficient, and really give you added value in terms of profit. Note, however, that oftentimes there might be a trade-off between some of these focus areas. It may well be that in order to have operationally efficient models, that sometimes you have to lose a bit on interpretability or vice versa. So there are some trade-offs between these various focus areas depending upon the application area. These trade-offs are often referred to by analytical researchers as the no free lunch theorem. That means if you want to get something, you need to sacrifice something else. There's no such thing as a free lunch. You always have to pay a price for it. That also applies in analytics as you're optimizing one type of criterion, but are losing something on the other on another criterion. What I found a very powerful enabler actually is visual analytics, because visual analytics is an enabler or mediator for two types of analytical disconnects, as I refer it. The first type of analytical disconnect is between the data and the data scientist. Real life data, as you guys encounter it in your business settings, is noisy, is time evolving, is unstructured. One way to find structure or to find patterns in this noisy, time evolving, unstructured mess is by using visual analytics. Using visual analytics, you can try and spur for patterns in those data sources. But visual analytics is not only used as a mediator to solve the analytical disconnect between data and a data scientist, but also the analytical disconnect between the data scientist and the business user. Because if a data scientist finds an analytical model that he or she feels comfortable with, that does not necessarily imply that the business user will feel comfortable with it. That's another bridge. That's another gap you need to bridge. All right? And that's again something that you can do using visual analytics. And in this presentation, I kind of illustrated that when I worked on the interpretability issue. Remember the scorecards that we used to bridge the gap between a logistic regression and a business user. Remember those colored representations, which we call nomograms, to bridge the gap between an analytical model and the business user. Remember the if-then rules that we used to do the same thing. That's really very, very, very important, right? That visual analytics. Another takeaway from my presentation is be very critical about new developments. I think there's a difference between deep versus smart learning, right? It's not because there's so many firms that tell you that you should do deep learning, that you should do machine learning. Machine learning is a term which has been in the academic world for a few decades already. Be very critical about those developments. Not everybody needs deep learning, right? Be very skeptical about it. I'm not saying that deep learning is a bad technology. It's a technology which is very powerful and which can offer a lot of benefits for the right applications. And that's really very important. You don't need deep learning to do credit scoring, if you ask me. You don't need deep learning to do churn prediction. You don't need deep learning to do customer lifetime value modeling. You do need deep learning if you're interested in image segmentation, in image search, in text categorization, and so on. For these type of applications, deep learning is very important. In other words, do smart learning instead. Critically, carefully analyze these new developments and decide which one you can use to your advantage, yes or no. I hereby wish to conclude my presentation. In case you'd be interested in some follow-up information, you can go and visit our dataminingapps.com website. As I said, we feature a 2-weekly newsletter. You can find various books which we published on there. Unfortunately, not for free, but you'll find links on there that take you to the Amazon website or any other publisher that published the books with us. Our most recent project that we've been working on and that we already completed, but our publisher is working on, is Principles of Database Management. We have a website, www.pdbmbook.com. You can log on there. You can find a very detailed table of content from our book. You can leave your name behind. At this very moment, Cambridge University Press is kind of working on our book. They still need a few months. Should be ready around June. But in case you'd be interested, feel free to sign up there and take a look at what we're doing. Thank you very much.